Hello everyone, my name is Charanaditya S. I am working as an assistant professor in the Department of Food Technology in Hindustan College of Engineering and Technology, Coimbatore. So today we are going to discuss one of the topics that is included in the fluid mechanics, that is compressor. So what is the use of a compressor? Compressor is the mechanical equipment which is used to increase the pressure of the air or water, in this case by reducing its volume. They are somehow similar to the pumps that both increases the pressure and both transport the fluid through their pipes. So compressor types on the basis of its displacement. There are two. First division, there are positive displacement and dynamic type compressors. In positive displacement, it divides into reciprocating and rotary. Under rotary, under rotary comes lobe, liquid ring, screw, scroll, and vane. Under reciprocating comes single acting, double acting, and diaphragm. So under dynamic, there are only two types. One is centrifugal and one is axial. First one, positive displacement. So positive displacement compressors are compressors which compress the air or fluid by the displacement of a mechanical linkage and by reducing the volume. There is a piston driven shaft crankshaft at the bottom. This diagram contains, and when the inlet the fluid is flowed through the inlet, the piston compresses the fluid and discharges through the outlet wall. Next is reciprocating compressor. These compressors use the piston driven by the crankshaft. They can be either stationary or portable. It can be single staged or multi-stage and can be driven by the electric motors or internal combustion engines as well. They are made for intermittent duty. So in this also you can see there is a piston involved and there is a inlet valve and a discharge valve. Single stage has single cylinder, and double acting compressors have single piston but two discharge valves and two suction opening valves. And multi-stage compressors, there are two or more cylinders instead of one cylinder. So this is the inside label diagram of the multi-stage. Advantages and disadvantages of reciprocating compressors. Next is rotary compressors. These compressors does not have any reciprocating motion. In fact, it has rotating motion with screws, scrolls, and vanes rotating alongside a shaft. Screw compressor, a type of gas. First one is screw compressor. It is a type of gas or fluid compressor that uses a rotary type positive displacement. They are used in place of piston compressors where large volume of air compression is needed and without intermittence. That is large quantity without intermittence. It has a pair of helical rotors where it traps air as the rotor rotates in the cylinder. The male rotor and the female rotor are being built inside the cylinder for compression. They are generally used in large industrial areas. So this is the screw compressor diagram. You can see there are two screw-like structures inside which functions in opposite directions, and it compresses when the liquid travels through the insides of the screw, it compresses the liquid and sends it out. Next is scroll or spiral compressors. As a a scroll compressor has one fixed scroll which remains stationary all the time, with another orbiting scroll which rotates through the use of swing link. So one rotates and one is stationary. So when the rotating when the rotating vane rotating scroll comes in contact with the stationary scroll, it compresses the liquid which is passed through in between. So this is where compression. Rotary vane compressors consist of a rotor with a number of blades inserted in radial slots in the rotor. As the rotor turns, blades slide in and out of the slots, keeping contact with the outer wall of the housing. Thus, a series of increasing and decreasing volumes is created by the rotating blades. They can be either stationary or portable, can be single stage or multi stage driven by electrical motors or IC engines. So this is a pictorial representation of the vane compressors. Next is rotodynamic compressor. The compression is carried out by a rotating element which is imparting velocity to the flowing air or gas, and hence developed desired pressure and compression is achieved. Understand? Please understand. Desired pressure and compression is achieved by the dynamic action of rotor. There are two types of dynamic compressors. One is centrifugal compressor and one is axial compressor. First one, centrifugal compressors. They use a rotating disc or impeller in a shaped housing to force the gas to the rim of the impeller, increasing the velocity. A diffuser or divergent duct converts velocity energy to pressure energy. So this is a centrifugal compressor. As you can see, the rotation takes place. Next is axial flow compressors. Axial flow compressors are dynamic compression that use arrays of fan-like airfoils to progressively compress a fluid. They are used where high flow rates or a compact design are required. The array of airfoils are set in rows, usually as pairs, one rotating and one stationary. These rotating airfoils are known as blades transport and compress the fluid. The compressors can have high efficiency of up to 90%. So this is an pictorial representation of the axial flow compressors. That is one part turbine. So this is the process flow diagram of a compressor. So hope you understood the following session. So basically compressors compress the liquid or gas or air or fluid, and high pressure is created so to achieve the desired flow rate. So basically compressors compress the fluid. That's it. Thank you for listening.